Hi, a very warm welcome to the Quick Solutions All India AIATS Test Series JEE Main 2020 Test 6 Physics. Let's go to question number 1. Question 1 says a thin spherical shell of radius r is projected horizontally on a rough horizontal surface with linear velocity v0 and without initial angular velocity. Its angular velocity after it stops slipping on the horizontal surface is, well, the question is based on the topic rotation, of course. There is rolling involved. In fact, initially there is rolling with slipping. Finally, the motion will be rolling without slipping. Now, if we look at the situation, it's something like this. This is a rough surface, and on this rough surface, there was this thin spherical shell. Initially, it was projected with purely a linear velocity v0, and because of friction, it eventually starts rolling without slipping, and when it starts rolling without slipping, let's say the linear velocity has become v and its angular velocity has become omega. So now we can conserve angular momentum about this point, in fact any point on this line, because the torque of friction about any point on this line is going to be 0. So conserving angular momentum about this point, initially the angular momentum is simply mv0 r. So I'm writing in short. So this is short for conservation of angular momentum. About this point means that we have, if the mass is m, so it's mv0 r. That is the angular momentum about any point on this line. And this is equal to, finally when it starts rolling without slipping, we have mvr plus I omega, and I for thin spherical shell is 2 by 3 mr square into omega, and since it's rolling without slipping, omega can be written as v by r. So this is the equation. Initially there was only purely a translatory motion, that's why there is only mv0 r term. I omega term would be 0 because omega was 0, and when slipping stops, well, we have both these terms. So now if we look at the right hand side, what we have is 5 by 3 mvr, and this in fact gives us the value of v as 3v0 by 5. So we have to find the final angular velocity. So final angular velocity omega in fact will be v by r, and that means it's equal to 3v0 by 5r. And if we look at the options, we can see that it is matching with option 4. So option 4 is correct for question 1. Let's go to the next question now. Question 2 says particle A moves along x-axis with a velocity of 12 meter per second, and particle B moves with a velocity of 20 meter per second along a direction, making an angle of 53 degree with the x-axis. See figure. The velocity of B relative to A is, and in the figure we can see that it's the XY plane, and velocity of B makes angle 53 degree with the x-axis. Now we have to find the velocity of B relative to A. Well, we can assume that the velocities given are respect to ground. That means velocity of A respect to ground we can take to be 12 meter per second along the x-axis, and velocity of B respect to ground can be taken as 12 meter per second along the direction shown, which actually makes 53 degree angle with the x-axis. So if I simply apply velocity of, we have to find velocity of B respect to A, and the concept is that it's equal to velocity of B respect to ground minus velocity of A respect to ground. So to find VBA, we need to put VB and VA in vector form. We can do that. So let's put VB in vector form, and VB in vector form if I put using I cap, J cap unit vectors, well, it's 20 meter per second at angle 53 degree with the x-axis, so it is 20, and well, along x-axis it is cos 53 degree I cap, and along the y-axis then we can write it as 20 sine 53 degree j cap. So with the other term is sine 53 degree j cap. So this in fact is the velocity of B. Let's simplify this, and then this comes out to be equal to 20 into cos 53 degree. Cos 53 degree we know is 0.6, so that means it is 12 I cap, and the other term will be 20 sine 53 degree j cap. Sine 53 degree we can take as 0.8, so that means it is plus 16 j cap meter per second. And if you look at velocity of a with respect to ground, well, that is pretty straightforward because it's along the x-axis, so it is 12 I cap meter per second. So velocity of b with respect to a, if we look at, we see that it is vb minus va. That means it is 12 I cap plus 6 j cap minus 12 I cap, or it is simply 16 j cap meter per second. Now if you look at the options, the first option says it's nearly 27 meter per second along the bisector of angles between the two velocities. Option 2 says nearly 27 meter per second along positive y-axis. Option 3 says 16 meter per second along positive y-axis. In fact, this is matching with what we have got. So option 3 is correct. And let's just go through the option 4 too, and that says 16 meter per second along negative y-axis, so it's incorrect again. So for question 2, option 3 is correct. Let's go to the next question now. Question 3 says, in the arrangement shown in the figure, the string and the pulley are ideal. The acceleration of block B is, take g as 10 meter per second square. The surface has been shown as smooth, and there's a force of 20 Newton being applied here. So at this point we have to find the acceleration of block B. Well, we can say that the question is from the topic laws of motion, and there is a bit of constant relation also involved here. So let's assume that tension in the string is T, and this one A is going upward with acceleration A1, and B is going towards right with acceleration A2. Now if we look at block A, the forces on block A are of course 2g downward and T is upward, tension in the string. And we have of course assumed that acceleration is A1. So the equation for block A is T minus 2g equals, so we have T minus 2g. 2g is the weight of the block, 20 Newton, and this is 2 times mass times acceleration, so 2a1. This is our first equation applying Newton's second law for block A. And for block B, well, the equation would be, horizontally we can say that the two forces are 20 Newton and the component of tension in the opposite direction, and that would be tension T cos 53 degree. So the equation for the other block is 20 minus T cos 53 degree, and that we can put of course as 0.6T is equal to 3 times A2, where A2 is its acceleration. This is our second equation now. And let's now look at the constant relation between the two accelerations. We have assumed that here acceleration is A2, so along the length of string, if we see, it becomes A2 cos 53 degree. That means we have A2 cos 53 degree is in fact equal to A1. So what we have done is we have used the fact that in this particular case acceleration at the two ends along the length of string will be equal, which in fact gives us the relation A2 cos 53 degree is equal to A1, and we are interested in finding A2. So let's put value of A1 as A2 cos 53 degree in the first equation. So the first equation we rewrite as T minus 2g is equal to 2 times A1, and it is in fact equal to 2A2 into cos 53 degree, which is 0.6. So this is equation 1 written again, and we are now interested in eliminating tension from equation 2, and we can call this equation 3. So to eliminate tension, well, let's multiply equation 3 again by 0.6. So what we have is 0.6T minus 1.2g is equal to 0.72A2, right? So that is what we are getting it on simplification. Let's call it equation 4, and we now add equations 2 and 4. And if we add equations 2 and 4, what we have is that 0.6T term gets cancelled from the two equations. 20 minus 12, so that means 8 is in fact equal to, we have 3.72A2. So 3.72A2, and that gives us the value of A2 as 8 divided by 3.72 meter per second square. That will be the unit. And if we simplify, this is about 2.15 meter per second square. That is after division, of course. So for question 3, well, option 1 is correct. Let's now go to the next question. Question 4 says 3 very large plates of same area are kept parallel and close to each other. They are considered as ideal black surfaces and have very high thermal conductivity. The first and third plates are maintained at 3T and 4T respectively. The temperature of the middle or second plate under steady state condition is, so that means in this case we have to find the temperature of the middle plate under steady state condition. Well, the situation is something like this. We have 3 very large plates. Let's arrange them like this. So this is the first plate, this is the second plate, and let's say this is the third plate. The first one in fact is maintained at temperature 3T and the third one is maintained at temperature 4T. So this is maintained at 4T, and assuming steady state conditions and ideal conditions, that means we are considering that these plates are ideal black surfaces. Well, so what will happen is, let's assume that the temperature of the middle one is, let's say, T2. So whatever amount of net rate of flow of heat between the third and second, the same rate of heat will flow also between second and first, because none of these plates will absorb heat as such, right? So whatever amount of heat is absorbed, the same amount of heat is being radiated. So that net absorption is 0. That is the condition for steady state. Otherwise the temperature will change with time. So if we look at the net rate of flow of heat between the third plate and the second plate, that is, let's call it H, and let's consider it for area A for all the 3 plates, right? Because for infinitely large plate the quantity will become infinite. So we are taking area A for each of these plates, and then the rate of heat flow becomes sigma A, and of course that means 4T to the power 4 minus T2 to the power 4. That is as per Stephen's law. Similarly, this is also equal to sigma A and net rate of flow of heat between plate 2 and the first plate, and that in fact we see that it is equal to T2 to the power 4 minus temperature of the first one, which is 3T raised to the power 4. This is also H. Now to find T2, of course we can equate the first 2 equations. We are naming them equation 1 and equation 2, and if we do that, what do we have? Well, what we have is that 2 times T2 to the power 4 is equal to 3 to the power 4 plus 4 to the power 4 into T to the power 4. Let's simplify it. 3 to the power 4 is 81 and 4 to the power 4 is 256. So this is then 81 plus 256 into T to the power 4. Let's further simplify it. Let's do the addition, and if we do the addition, this is in fact 337 T to the power 4, and of course on the left hand side was 2T2 to the power 4, and that means that the value of 2T can be taken as 337 divided by 2 raised to the power 1 by 4 multiplied by T. And if we look at the options, we can see that option 4 is matching with what we have got. So option 4 is correct. Let's now go on to the next one. Question 5 says the shown PV diagram represents the thermodynamic cycle of an engine operating with an ideal gas with degree of freedom 5. The amount of heat extracted from the source in a single cycle is. Let's analyze the situation here. Of course, there is a thermodynamic process involved. So the question is from the topic thermodynamics, and it is in fact related to the efficiency of a cyclic process. So now we have to identify the processes in which heat is being absorbed from the source. So if we look at the process AB, the process is in fact isochoric, but the pressure is increasing, the temperature is increasing, and so heat is being absorbed. So heat is being absorbed in process AB, so that will be of interest to us. So let's say we are interested of course in delta QAB, the heat absorbed in process AB, And in process BC, again, what is happening is that process is isobaric, but gas is expanding, doing positive work. The temperature is also increasing. So here also heat is being absorbed. Heat is being absorbed in the process AB as well as in BC. And if we look at process CD, it's a isochoric process in which product of pressure and volume will decrease, so temperature is decreasing. So in process CD, heat is not being absorbed. In fact, it is being rejected by the system. So that will go to the sink. And in process DA2, process is of course isobaric, but volume is decreasing. So that means heat is being rejected once again. So we are interested in delta QAB plus delta QBC, because these are the two processes in which heat is being extracted from the source, whereas in the other two processes the heat is being given to the sink. So let's find delta QAB and delta QBC. For delta QAB, in fact it's a isochoric process, so delta QAB in fact is simply equal to delta UAB, because work done is 0 in this process, and that will be number of moles. Let's say number of moles is N into CV into delta T, that means TB minus TA. And we can put the value of CV because the degree of freedom is given as 5, so CV is 5R by 2. So this in fact becomes N times 5R divided by 2 TB minus TA. And applying the ideal gas equation, that PV equals nRT, we can see that nRTB can be written as 2 P naught V naught and nRTA can be written as P naught V naught. So that means delta UAB in fact becomes, let's write again, delta UAB is then 5 by 2, nRTB is 2 P naught V naught minus nRTA, which is P naught V naught. That means we have it as P naught V naught. That is as far as delta UAB is concerned. Let's now write delta QBC, and we can see that the process is isobaric expansion. So this in fact will be given as NCP delta T. So NCP and delta T in fact is TC minus TB, and the value of CP we can write it is CV plus R. The CV was 5R by 2. So CP will be 5R by 2 plus R, that means 7R by 2. So this is N into 7R by 2 into TC minus TB, and then nRTC is in fact equal to product of volume and pressure at point C. The product of volume and pressure at point C in fact is 6 P naught V naught. So this is then coming out to be 7 by 2 into nRTC, that is 6 P naught V naught, and minus nRTB, and that will be 2 P naught V naught. So this we find is coming out to be, well, this is 4 P naught V naught by 2, 2 P naught V naught into 7. So this is 14 P naught V naught. So the heat absorbed, or rather the heat extracted from the source in a single cycle is delta QAB plus delta QBC, and this we can see that is coming out to be 5 by 2 plus 14 into P naught V naught. So this is 5 by 2 plus 14 P naught V naught, and this will simplify to 33 by 2 P naught V naught. And if we now look at the options, we can see that it is matching with option 4. So option 4 is correct for question 5. Let's go to the next question now.